We run a small company out of Boise in our spare time and in my garage that develops a smart ski pole. And the goal with the smart ski pole is to help folks like you navigate avalanche terrain by looking at the snowpack quickly. We call it the Lyte Probe. The goal with it is to make something pretty robust. So we do a lot of tests like what happens if you tomahawk it across a really large area and it hits a tree. We want to replace some of your gear, but not add to it. So the idea is that we replace one of your ski poles and you have no extra gear added. We're doing some new stuff with near infrared, so it's not hardness or probably anything that you're accustomed to, and I'm going to elaborate a little more on that. And then we're doing some really cool data digesting stuff. So when you can take measurements with this thing in 30 seconds, you end up accumulating a lot of information, and then it becomes, okay, well, how do I even use this information? And I'll go into a little bit of that. It's just this guy right here. This is the latest and greatest. It's got a removable basket that comes off the bicycle clamp, and then it becomes a sweet snow spear. So if you need to defend yourself from some mean bears, you can definitely do that. This is the team that does it, and all these guys work part-time on it, usually really late at night. There's 7 of us. I'm kind of the concept guy, go and make sure that the sensors we're using actually make sense and have real value to snow people. Drew is the top middle guy. He's our money guy, makes sure that I don't spend too much money. Adrian on the far right, he's our electrical guy. We got a couple software guys. Ryan is this guy in the maroon shirt, so if the ski pole feels funky, you can blame him. And then Jake in the blue shirt in the bottom right, he's our resident ski bum, and he actually goes out and uses the ski pole to make sure that it skis decent. So at this point, you might be thinking, oh, brother, here's another smart probe. Like, what's the big deal? We don't really care. We've seen these things kind of come and flop, and I'm not going to name names. But I think you'll find that the way we're doing things is pretty different from traditional or previous approaches. We're pretty focused on working with folks like you. There's several people in this room that have used our prototypes, and we frequently converse with those people, get feedback, we make changes, and we try again. Sun Valley is great for us because we're in Boise, so we come here and there's snow, and people at Sun Valley and Scott are all really great resources for us. The big thing about this team is that none of these folks are avalanche professionals, at least in the sense that you folks are. We don't make any real decisions in the snow other than trying to better measure it. So feedback from people like you is really important to us because we don't have really that experience to make critical decisions. We're pretty focused on just delivering important information to you guys, so sometimes our prototypes don't look super glamorous. There's one back there that's got a behemoth handle on it, which ended up being a bigger issue for a lot of people who ski. We're big into open data, so all the data that you collect and store is put into a CSV, so if you know how to use Excel, you can look at the data in whatever manner you want to look at it, and we can get it to you pretty quickly. It comes in a Dropbox, and it's all syncing through your phone, which is, we think, really important to this aspect of collecting this kind of information, that the people who are getting it should be able to use it whenever they want. Like I said earlier, this operates out of my garage, so my garage is just packed with really random techie stuff. We have a CNC machine and a little lathe that allows me to make parts really quick. And I think a really important thing here is that we do a bunch of testing, so before it even sees anybody else, we've been out. We try to get out 15 times a year and do pits, and we're all kind of self-taught snow scientists, so bear with us on any of our results. But before anybody else touches it, we've already used it a bunch to make sure that it makes sense and that it's not this just super quirky thing that we're going to put into the snow. And then we test with a whole bunch of people across the western U.S., and now this year, for the first time, we have scientists doing stuff with it. So that's pretty exciting for us. And so there's this kind of several perspectives that are coming into it, and we're retrieving all this information and trying to come up with tools that actually help people work in avalanche terrain. And then second, the final piece here is, and I think maybe one of the biggest pieces that makes us different, is we don't take ourselves too seriously. We operate in a garage, and we're doing things that people haven't seen before, and so we expect that sometimes people are going to be like, this is just total garbage. Like, what is this? So this is a picture of Ryan trying to distract Jake while he's in an interview when K-12 came and wanted to do a piece on us, which is kind of fun. So you might be thinking at this point that I said infrared earlier, so that's not hardness. What is it? So we're using near infrared. Specifically, this is emitting infrared light. We measure how much comes back. We do that in the 750 to 850 nanometers range. We're trying to use multiple sensors to measure responses from different grain types with the hopes of finding some special information about specific grains. The thing I think is really interesting about this group of people is that there's quite a bit of research that happens in near-infrared in snow, but hasn't really made it outside of the academic realm. Part of it's that there's a lot of complex things that are happening there, and we're trying to bridge that gap with something like this. Specifically, a lot of people started looking at it with satellites and measuring snowpack from space. And then in the last 20 years, people started doing open pit photography. So they dig a hole in the ground, they prep a surface, they take a picture, and they process and get out a whole bunch of information. And then there's been some spectroscopy stuff where they blast a bunch of wavelengths and the near infrared comes back really interesting. So snow scientists are definitely using it. Most of them focus on this variable called the specific surface area, which is the surface area of a grain divided by its volume. And they use that in all sorts of modeling pieces, and it really tells you some interesting stuff about what type of grain you're looking at. So if you can think like a dendrite has a lot of surface area, but not really a lot of volume to it, so it's a really high specific surface area. A couple of key scientists here, Alex Linglow out of Canada, was able to show that the SSA actually comes back to real geometric grain size, so there's a real physical parameter that you can tie in that people are semi-familiar with. This guy Picard was able to show that measuring that is actually affected by the grain shape. And then our own H.P. Marshall out of Boise has done quite a bit of work in it, but one of the pieces I think is really interesting is that he's measured layer thicknesses across a small area and looking at layer continuity. So what does all this mean? Well, NIR is pretty great at showing stratigraphy. You can see layers pretty clearly. It's controlled by the grain size and shape. So that's the piece I think is really interesting for this group of people, that the shape piece, we could conceivably put grain shapes as a function of depth. So you could see that there might be facets at 20 centimeters or whatever. Faceted crystals particularly show up extra dark. And then water in the snow also reduces the reflectance. So there might be an application for wet avalanche research. So we've been working on this since 2014. This is me cheesing it up at Galena with one of our first prototypes. Originally, we started trying to look at transmittance, so we'd shoot light across this little PVC tube that I made and measure how much light got across. Scott here quickly told me that near-infrared might be more interesting than trying to do that. This was a super crude process, but it was kind of like our first steps into the snow, which was fun. The following year, we built 2 prototypes that made it into the snow, and we were using infrared. It's the first time we started trying to look at how the light's returning off of different grains. And for the very first time, we were able to see buried surface hoar, and it was pretty clear in some of the measurements we were taking, and that was like mind-boggling for us. Last year during Snowpocalypse, we actually made it into a decent ski pole. That's what that one is. Decent's a relative term. A lot of people really didn't like it, and it was super heavy. We were able to actually start collecting data through an app, which was a big piece, and we're able to sync all that remotely, which makes things really easy for transferring stuff. We were able to test with a bunch of people, which I think is a testament to how easy it was to use. We collected 1,200 measurements with those folks, and then we did another 2,800 in-house. We attended ISSW, and we wrote a paper called Bringing Near Infrared to Practice. And it's the first time we actually had decent depth measurements. Up until that time, we were kind of guessing and trying to do it, but we've got new sensors that allow us to measure depth reasonably. This year, we really changed the handle because we got a lot of feedback saying that large handles suck while skiing. We reduced the weight of it, which was the secondary complaint. The big thing that was kind of interesting is last year we were seeing a lot of near-infrared from the sun penetrating the first kind of 15 centimeters of the snowpack, and so it was kind of distorting our measurements. So we added an ambient sensor to be able to pull that off. And this year is the first time we have software that is available for scientists to do their own research. So the probe in itself is very open. We do our own processing on the app side, but a lot of researchers don't want the way we process it because they want to do their own research. So we've kind of opened up the platform so that folks can keep doing their own research. So in all that testing, some things that we found it does well. Right off the bat, with some of the earlier prototypes, it could measure really small layers. And I think this is one of the big benefits of using kind of an optical approach to assessing a snowpack versus, say, using a hardness sensor or something. Because there's really thin features in the snowpack, sometimes the size, like for hardness, for instance, if you hit the size of your tip is going to dictate some of the resolution that you can measure stuff at. So we were able to see millimeter-sized layers early on. We also because of the limited snow, we used ice skating rink shavings, and then we would put knife cuts in the snow and then pack it together. So everything was pretty much the same except for our little cuts. It was crude, but it showed us that we were making progress. Because we have decent snow depth measurements, we can actually look at really early season conditions. This is me at Anthony Lakes here. I think there was like 40 centimeters, but that Thanksgiving crust was visibly showing up in the readings, and since there wasn't a lot of snow, it was kind of fun to see it all by itself in the snow. We're measuring near crust faceting pretty well. Here's some rounded or some faceted grains there sitting on top of a sun crust. And what was interesting about this was at Soldier Mountain this year, and we had a reactive ECT that was going on top of that. That's one of the first times we've been able to link all that together. With near infrared, there's not a direct link to stability, so I'm not trying to imply that, but it was the first time that we were distinctly measuring a layer that was reacting, which was pretty cool. And then this was from one of our earlier prototypes where we saw this is our first surface hoar measurement. You can see that the level of detail is different, but that bottom section there was where we first saw it at Moores Creek in 2016, which is pretty exciting. So with any project that you're doing out of your garage, there's going to be room for improvement. We kind of feel like the depth is the key to all this. Like if you can't measure depth accurately, you're going to miss a whole bunch of stuff. And so right now we're measuring within 10% of the overall depth measurement, which isn't quite good enough in our opinion. So that's something we're working on. The near surface stuff that I mentioned earlier about ambient light, that's something we started working on this year. We don't have that method quite down, but we actually have data on it, so that's certainly helping towards that process. And then because we're doing something new, there's kind of this in-field interpretation piece that leaves you wondering, what am I looking at, even in the field? And because it's not hardness and because it's not density, you're kind of left in no man's land. I'm probably the only person that can start seeing crusts in it, but that's because I've been looking at it for like 5 years now. So we're trying to come up with methods of how to digest that information better for you guys. And with that, we're doing a whole bunch of research on our own and writing our own papers. One thing that we're particularly interested in doing with it is characterizing a large area. So we're using this shape comparison algorithm that's similar to voice recognition. So Siri in your phone knows what hello sounds like, and if you're from the South, you might say hello, and Siri goes, oh yeah, I know that's hello. And so the way it does that is it looks at the shape of the signal it gets and stretches it and shrinks it to try to match it, and then says, okay, this is the right match. We're using that with these profiles because they end up being really crazy sometimes. And by doing that, we can then say, okay, well, how different were these profiles as I took them? This is a day I had last year at Anthony Lakes again. Again, I'm from Eastern Oregon, so I'm there frequently. And this kind of ridge line you can see here where it turns yellow was where we expected it to be the most different because it's really wind blown right there. And so this was kind of our first hint that we might actually be capturing some real information that's valuable for navigating avalanche terrain. One of the extended pieces we want to do with this is look at slabs. So once we get our depth down a little bit better, we'll start measuring slabs by looking at their shapes. That's something we're pretty excited about. That was also a recommendation from Scott. We attempt to look at density, but you can see with this plot here, there's not a ton of structure. It's an ongoing research experience. The variables that go into it are complex, and even in the scientific literature, it's still pretty loose if you do get there. The big thing that I'm really excited about is I think that we're going to be able to identify grain types in the future and then place them by depth. This is a pretty cool measurement that we took up at Baldy. I think this is the day you and I went out, Scott. And we were able to find facets above and below this crust, or this ice layer. And then the thing I thought was really interesting was seeing the depth tour and melt forms kind of alternate and these more subtle features that I don't really pay attention to most of the time. But they lined up really nicely with these with the hand profile. So if you're interested in maybe getting involved, there's a few ways you can do that. You can always get a first generation probe, which is the crappy ski handle one. And if you can tolerate it, we're always open to people gathering observations side by side with it. The probings themselves take usually less than a minute, depending how many you have on your phone. So the probe side of it doesn't actually take that much time. For us, the time-intensive piece is the pit prep and all that stuff. And we're not very good at identifying grains and doing hand hardness profiles. So folks like you, it's really handy to have. If you're really, really into it, you can buy a probe. We don't have many of them for sale, but you're always welcome to try to buy one. And mostly in doing that, we want you to participate in the learning process. We're not saying, here's this awesome good that's ready to go. Like, we want you to come back and say, here's how it could improve, and then we make those changes. Certainly providing feedback and ideas on what this information could do for the communities, something we're interested in. And then you can follow our progress with our newsletter. We get one out monthly that mostly highlights me and my 2-year-old in the garage making a mess. What's next for us? We're going to keep focusing on depth measurement accuracy. We're actually going to start producing some digital depth probes that will help in that process. We're going to start making better ski poles. Black Diamond is no longer tied up with previous smart probe folks, so they're going to partner with us and let us buy some of their ski poles and put our technology in it, which is going to be great because we're not very good at making ski poles. We're perpetually working on a 2-meter one. The Idaho Department of Transportation is interested in that. And then one thing that we've lacked pretty much this entire time is decent software for looking at your measurements, especially outside of the field. So right now you can only see them on your phone. We're going to start collaborating with SnowObs, which is Scott Haven's snow observation website project. He's doing a major overhaul, and there's going to be some plugins that are set up for the probe so that you can actually view your data on a map. Thanks. Any questions?